All right. I think we're about two past the hour now. So Tim and Brandon, Tim Ebers, our field CTO and VP of Customer Engineering at Wallarm, and Brandon Shope, our Senior Solutions Engineer here at Wallarm. I'm going to let you guys have the floor. So thank you so much.
Sounds good. Thanks, Brandon. Yeah, excited to be here. Brandon and I have been working together for a couple of years now. We have the pleasure of working with all of our prospects and customers and doing a lot of architectures and deployments. And so today we want to talk a little bit about kind of what we see overall in the API security space, how we can do deployments and what they look like, and do a little bit of architecture. What we're not going to do is give you a bunch of slides, so we're going to try something new. So bear with us if we do have some technical difficulties. We practiced a couple of times, but I think this is going to work out. So hang on with us if we do have to flip some things around, but I think we'll be okay. If you have questions, please feel free to throw them in the question and answers. We'll see them and we will ask or answer them as we can as we flow through the conversation. So Brandon, you want to get a little bit about your background?
Yeah, no, thank you everyone for spending some time with us today. Yeah, I've been kind of all over the place. Done a lot of infrastructure work, worked for Citrix and Brocade, and some software load balancing and application delivery and API gateway via Nginx at F5, and that's really kind of brought me here to Wallarm, and moving into more of the security bent of of all of that, but it still plays so well together with that infrastructure background. And that's really what we're going to get in today is the architecture and some diagramming and drawing, which is the wheelhouse of the infrastructure folks. So I'm excited to spend some time with you today.
Great. So let's first start talking about why it's important to consider how you're going to deploy a security product.
Yeah, so really it gets into what I kind of already hinted at in my background is, when we're now working with the security teams, and the security teams have to play well with the infrastructure teams and then the application owner teams and the API owners. So it's a balancing act. It's always a balancing act of bringing everyone together to the table and being okay with changes and what level of changes to what already works and what we are all confident works and what we, put our confidence in every day of whether or not we're going to have outages or anything like that. So it's always this balancing act of getting the most out of the solution, whatever security solution that may be, and especially with Wallarm, and we have many different deployment options that fit into those different scenarios of everyone cooperating together. And that give and take of do we want the whole feature set? Do we want to be inline? Do we want to be able to do blocking? Or is it more critical upfront to have visibility into what's going on, an inventory of APIs and things like that? So that's one of the things we always work with our customers is landing in on that balance of what works for them and what allows us to bring the most value from a security platform.
Yeah, and when we're working with customers and prospects, how often do you see a security organization that has a set of requirements and then an infrastructure group that has a set of requirements and an application group that has a set of requirements, and trying to meld all three of those together into solutions is kind of what we do. And it's kind of why we love our job, is because we get to help folks down that path and understand the best solution for them to get the best security across the board. Do you agree with that, Brandon?
Yeah, absolutely. I mean, a lot of times we'll start with a great initial, demo presentation of all the bells and whistles and security teams all ready to deploy all of that, and then we bring the other players to the table, and we have to unfortunately start paring things back sometimes. But in an ideal world, we can deploy everything and bring everything to the table.
So let's talk a little bit about the types of deployment that we typically deal with the most, especially with our product. So we've got three different types of categories. We've got inline, we've got out of line, and we've got hybrid. Why don't you explain what the difference between the three are?
Right. So typically, inline, this is where we're going to have the most friction probably with the application owners and infrastructure folks, because we're going to want to actually put our solution, our appliances, our filtering nodes in the line of traffic. Right. So now that gives us full access to the traffic decrypted. We can do our deep inspection, and most importantly, then we can also do our real-time protection and mitigation of malicious attacks at a per packet level, right? That's important. And so, it's you get everything, but it's going to have to require everyone to allow some things to be moved around in their infrastructure, right? So it's a new thing in the line of traffic. It's going to add some, no matter what, you put a new appliance in the line of traffic, you're going to have new network latency on the front end and the back end. You're going to have a little more latency from encrypt decrypt cycles. It's just inevitable, no matter what vendor solution it is. But that's the ideal scenario. Gives us all the capabilities of the given product, especially for the blocking, real-time blocking, if that's critical. That a lot of times, is like a direct integration into maybe a Kubernetes ingress controller, standalone VMs in a traditional data center or in a cloud deployment, or our own SaaS, or as a, so we provide the whole solution as a service if the customer wants, and that includes the filtering nodes, and we can put those on the edge, and provide that turnkey protection. But again, it's going to be in the line of traffic. Then we have our out of line or out of band type of deployments. Typically, that's going to leverage some sort of device mirroring of something that you already have in line that has the capabilities to mirror traffic or mirror packets to something else. So you can do that, with F5 appliances. You can do that with, Nginx, Envoy. There's lots of different existing vendor applications or VMs or appliances out there, or hardware devices that are capable of mirroring decrypted traffic. And what we do is we still deploy our filtering nodes, but then we mirror that traffic to those filtering nodes, and they functionally inspect the traffic just like they would in line, but in this case, they're to the side of the traffic.
And so
And
we
then
don't block traffic with out of line, at least directly as the request is coming through, correct?
Yeah, correct. And out of line, it's really this concept of pure out of line. There's going to be no manipulation of the traffic or packets as it flows through. It's kind of a fire and forget from the device doing the mirroring, and it's going to be kind of an asynchronous type processing of the traffic. And then lastly, we have our connector deployment, and that's where we directly integrate or leverage some sort of tech stack that's open and available to third parties to develop on, that allows us to integrate directly into another product. And a lot of times it's kind of a hybrid of the two, inline and out of line, where we'll still a lot of times be using the integration to mirror the traffic to the filtering nodes. But then a lot of times in those connectors, we have the capabilities to then, in our scripting, hold the traffic and wait for a response from the filtering node of whether or not to deny or allow the traffic. So it gives us kind of the capabilities of both of the previous deployments, the inline and the out of line.
Got it. Got it. So with the connector, these examples that you give here, there are some very interesting things that I see in these examples. So with the MuleSoft custom policy, how does that work with MuleSoft? Or will you get into that as we go into the architecture?
We can look at that more at the architecture, but it's basically a custom policy within the MuleSoft management system, and allows you to attach our custom policy at a per API level, and it functionally mirrors that traffic from that API as it traverses the MuleSoft platform to our filtering nodes.
And we can do both blocking and non-blocking with that, correct?
Yeah, absolutely correct.
So synchronous and asynchronous.
Yeah, and API discovery and all of that good stuff.
Yeah, great. So let's get into the architectures, if you don't mind. I'm going to actually give this over to Brandon so he can draw with us. And what we want to do is something that Brandon and I have started enjoying a lot of, which is drawing with customers as they tell us about their architectures. So what we're going to do is just do a little bit of drawing here. It's something that we have a lot of fun doing. So we're going to start with the inline architecture. So if we look at the inline architecture, Brandon, you typically have a consumer, whether that's another API or whether that's a customer through a web browser. You hit a load balancer, an API gateway, and then there's an application or an API program on the back end. How would you take our product and put that in line, or most products and put that in line?
Yeah. So, well, first, just a little quick overview for everyone. If you're new to the Wallarm solution, there's always two main tenets to the solution. There's the Wallarm dashboard, in this case, the as a service dashboard, and some type of filtering node is deployed. We have a whole menu of ways to deploy filtering nodes. There's no one particular deployment method for filtering nodes, but there's always the two parts, right? And the way we've architected this is it's a very security first, security focused architecture in those filtering nodes. So we've given the filtering nodes the entire power and capability to completely process the traffic, even do encrypt, decrypt, and then also do that blocking decision all on their own without sending traffic or mirroring traffic to the dashboard. And that's an important security focused differentiator for our solution, is the fact that our nodes, or other terminology other vendors might use as agents or sensors or anything like that, are not functionally mirroring your decrypted traffic to our dashboard in a giant data lake. We see that as a potential target, for a very juicy target, for a breach at some point. So what we've decided is we've said, let's have these filtering nodes be a completely separate operation. They do inspect the traffic in plain text, but it exists for milliseconds, and then it's destroyed. It no longer exists. And whether we're hosting those nodes for you or you're hosting the nodes, right, it gets even more secure if you're hosting the nodes. But if you choose to have us host the nodes, that functional secure separation always exists between the filtering nodes and the dashboard. So as I go through the different architecture and deployment types, you're always going to see this commonality of the dashboard and the filtering nodes, but there's always going to be that secure separation of the operation of the filtering nodes, regardless of how we're leveraging them in the architecture. That's how we've built it. So that's an important thing. So as these filtering nodes do filter traffic, they are syncing, reporting back to the dashboard, but again, not mirroring all the traffic. But we do send an entire packet if we see if the filtering node decides that is malicious, then we'll mirror that traffic. So there's a event stream and a record of any malicious activity. We can selectively blank out or remove any critical data. Like, for example, if you never want to see a token, or a particular header or something, we can blank that out from the filtering node to the dashboard. So don't let that even worry you as we're syncing any sort of full payload to the back end. We have redaction capabilities built in. But back to the architecture of the inline deployment specifically. So for example, let's say these are our SaaS-based nodes. So we're going to deploy these filtering nodes as a service. We would put these out here on the edge. It'd be very similar to some other vendors that use it's just CNAME record change, right? So these filtering nodes exist on our edge, and we're going to redirect your traffic to those filtering nodes for them to do the inspection, and then we will forward it on to the origin, just like you would configure several other, like Cloudflare or Imperva or something like that. Very similar concept. So we're going to redirect the traffic using DNS to the filtering nodes, do the full processing. It will be an inline, right? So we're going to get all the capabilities of the platform. We're including real-time blocking and mitigation on a per packet or per payload basis. And then we're going to forward the traffic on. You can bring that same concept inside. So if we wanted to say we were going to have this now in your infrastructure, these would be self-hosted now. And typically really similar design is still get them on that edge, or maybe behind a if it was a cloud, like a cloud edge load balancer. Typically we want to avoid having to replicate any specific load balancer routing or policies that you've created, or pools and things like that. So typically, if this is a, you know, the main load balancer that's routing all the traffic to the APIs and applications, or might be routing to an API gateway, typically we don't want to put it here, because we're going to have to replicate all of that and then maintain all of that also on our, you know, our proxy filtering node. So typically we want to try to get it to the left here. And then so far this is mostly like kind of traditional architecture, might be lift and shift into the cloud or something like that. But let's say we also might have, you know, a Kubernetes environment, and we got multiple APIs, and we got our applications. And we're gonna add our ingress controller. So this gets a little more complex, but we're gonna get everything here. So let's have applications talking to APIs. We have APIs talking to other APIs. And then we're going to have routes maybe just coming into this API from the internet and this application from the internet here. So the trick here becomes, how do we capture basically north-south and east-west traffic? And we want visibility and protection in this case. So we'll still need to leverage our inline deployment. But like we mentioned earlier, one of the integration points for an inline deployment would be directly into the ingress controller. So we can basically add the Wallarm filtering node capability to the ingress controller. So that gives us our north-south traffic in and out of the cluster. And then, but how do we get the east-west traffic? So we have a few different ways, but one of the common ways would be a sidecar. So we do a sidecar proxy with our filtering node, and these will get automatically attached to these applications and APIs as they spin up and down. And with the sidecar, that gives us, it is an inline type deployment, so it will still allow us to do the mitigation, the full inspection of even this fully internal traffic. So for example, from this API to this API, or, you know, from this application to this API, where that's internal traffic, that will allow us to capture and protect that as well.
So from your experience, what's the crawl, walk, run to an inline deployment? Because this seems complicated as you're talking about both north, south, and east, west. Is there a way to crawl, walk, run this rather than just big bang it into a sidecar with an ingress?
Yeah, and that's becoming more and more kind of a request from our customers as we talk to them, is I kind of want to start here. I have this immediate problem I need to fix. And a lot of times that's, I just need visibility. I just need, you know, an inventory of my APIs. I might want some mitigation. So, you know, it's, you know, really quick for us to spin up a POV with our as a service filtering nodes, and gets you that immediate north-south traffic coverage. And then, you know, you could build into this. You could build into then adding the filtering node or dropping these if you wanted it a little more isolated to particular cluster or Kubernetes cluster. And then lastly, add the sidecar if you wanted to. We also have, you know, eBPF, right, which would kind of gets us into our other deployment types, but the eBPF would be an option to just kind of get a quick visibility into the traffic of the cluster.
Sure. Sure. So
And then
since we're
sometimes it's a mixture of these other deployment methods we're going to get into, right? So maybe it's choosing a few different things from the menu, basically.
yeah, and we'll get into that at the end, but having a vast menu like Wallarm has is really important for enterprise customers as well as startup companies to be able to not have you change your architecture in order to fit the needs of our product. What we've done is made our product flexible so that we can meet the needs of our customers. So this is great. Let's go to inline and see what inline looks like.
Out of line.
Oh, sorry, out of line.
You're out of line. Okay. So again, yeah, we see the SaaS dashboard and the filtering node show up again. But this is where we're going to leverage the capabilities of maybe a load balancer or the gateway things. When you look at your architecture and your infrastructure team, we have a discussion with your infrastructure team, or you have a discussion with your infrastructure team, and you look at their diagrams and see what they already have. You say, okay, where in the chain of what we already have can we start to leverage that to mirror traffic to the filtering nodes, right? So now we can send copies of this traffic here, maybe from the API gateway, maybe you have a layer 7 API gateway or something like that, or Envoy. Or F5 load balancer, and mirror traffic to the filtering nodes. They again still do their traffic processing and then send their results to the dashboard for you to view. You're going to lose mitigation, right? So this wouldn't be on the table if absolutely necessary is blocking or mitigating attacks or API abuse. Bots, if any blocking capabilities are required, this would not be the way to go for you. But there's plenty of customers that it's a balance of some blocking is absolutely necessary, and some it's a nice to have. And so it's more about getting everyone to play together and get the insight and the data and all of that, and then this is the way to go, right? Or maybe this is our first step, and then everyone gets comfortable with this, and then we move into one of the inline options as well.
Right, right. So let's go to the last one, which is our connector architectures. So for us, our connectors basically take a piece of code that we put in with the particular software, like MuleSoft, like Cloudflare, Kong, Envoy. And what that piece of software does is basically duplicate the request and the response and send it to our filtering node. That allows us to be actually both inline or synchronous as well as asynchronous, depending on how you want to set it up. And that's totally controlled by the customer. So what are you setting up here for us, Brandon?
Yeah, I want to illustrate a few different things, right? So the versatility of the different options of where this integration might occur or the connector might occur. It could be in the load balancer, it could be in the gateway, it could be, outside here, MuleSoft or something like that. It might be there. It's very versatile. And like you said, it gives you that option of do I want the full mitigation capabilities, or maybe I just want to start with, again, this is about confidence and comfortable and making everyone comfortable with the changes to the architecture and solution is maybe we start with a connector, throw the switch for it to just be basically out of line or out of band, not do any mitigation. Traffic just passes through like nothing has changed, and then it's just doing that mirroring. And then we see, oh, that goes, oh, we have a lot of interesting attacks. We have a lot of bot issues. We're seeing that in the data. So we really think we need to turn on blocking. And now we have the ammunition to go to the other teams to say, see, we really need to turn on blocking. It's going to help you, right? Your service is going to perform better. Your customers are going to be happier. Your API is going to perform better. We're going to be able to peel off a certain number of abusive traffic. We have evidence of infiltration into systems and things like that, right? So now we have the case to turn on blocking, and then everything's sitting there, and we just throw a switch. That's the beauty of this, is just toggle a switch, and now we're blocking. But a lot of versatility in where it can be deployed, what type of integrations we have. But you can see here, I'm illustrating that, this is a bi-directional communication of potentially if we want to do the blocking. And also we could centralize the filtering nodes, or we could have filtering nodes distributed, all over the globe, and different connectors leveraging different filtering nodes. And one of the nice things about if you choose to have us host the filtering nodes is we have hops all over the globe, and we'll work with you to move those nodes as close to your origin as possible, so that we can bring that latency down that we might introduce from being in line.
And it looks like there's not much architecture change when you do a connector.
Right. You can see I didn't touch the core architecture at all. And I didn't change anything. I didn't ask anybody to change anything. I did add a connector integration, so a small piece of software or script to an existing vendor's appliance or solution, but I didn't functionally change traffic flow. I didn't put anything else net new in line. I didn't add any network latency on the front end or back end. I didn't add any encrypt decrypt latency. I'm just basically plugging into something that already exists, that's already doing all of that.
Yeah, and the no architecture changes is really really exciting when we move into proof of concepts or proof of values for our customers, because they don't know if they're going to buy us. We don't know if they're going to buy us. So why make architecture changes that people aren't comfortable with? So that's one of the big reasons why we brought out connectors, is because this is a great way for you to try our product, try to see what's going on in your environment that you may or may not be seeing today without architecture changes. And that's, we have a lot of customers that will use a connector during a POV, and then when they move to production or they purchase us, we'll actually change the whole deployment methodology, because now they're comfortable with us, and they are really excited to put us in line to be blocking those things that they saw during the POV. So that's one of the big reasons why our customers love our connectors, is because there aren't any architecture changes. So thanks, Brandon, for going through all of that. Let's go through the different pros and cons of the different types of deployments. So Brandon and I sat down and started going through some of these. So Brandon, why don't you handle the pros and I'll handle the cons for the inline deployments?
Yeah, so the biggest one right out of the gate, right, is anytime we can put something in line, we get that full blocking capability at a per packet level. And that's important, right? It's because you don't want to block by IP. You don't want to wait for a policy to be created and then synced and then implemented in another device that's in line to do the blocking. And then typically that has to be by IP, because we're not going to be able to do that fast enough on a per packet basis. So the idea here is that really leveraging that full capability of per packet filtering, which is critical for providing real protection, and not something that would be immediately disabled because of causing outages by blocking by IP address. It doesn't require third-party integrations or connectors, right? So it is, you're literally not touching anything else that's already there, but you are adding, something net new in the line of traffic. And in the case of using our security edge solution with our as a service dashboard, the whole thing can be turnkey, and we can get you up and running within minutes if you utilize our full as a service of the dashboard plus the filtering nodes.
Great, thanks, Brandon. So some of the cons, I think we've discussed this already, but we just wanted to put it all together. can be difficult to get buy-in from other organizations, infrastructure and application owners. You're putting a device in line, and that can be difficult to get buy-in from other groups. We have great visibility. We have Prometheus exporters for our product. We have lots of data. We've added a ton since we introduced our Security Edge, which is our SaaS-based product. So we have lots of ways to show and for customers to be able to monitor that, but it still can be, it can still, change is always difficult, and adding an additional device can be difficult at times. We'll add latency. There's no way to avoid latency at a network hop. Now, how bad is the latency? For our particular product, it's a couple of milliseconds, and then it's the network hops on either side. So it's not a ton, but depending on the industry you're in, a couple of milliseconds can be a lot. Some industries, a couple of milliseconds is no big deal. So a lot just depends on the industry that you're in. And then it creates another point of failure. So it's another architecture that you're going to have to create a highly available environment for. You're going to have monitoring set up, alerting set up, right? You just don't put something in line to your production traffic and go, it'll work fine. There's time and effort into doing that. Anything else you'd add, Brandon?
No, not in this point. No.
Oopsie. So let's talk about the out-of-line deployments. Why don't you do the pros again?
Yeah, so here we move away from that last con of, that harder to get buy-in from infrastructure. So this makes it easier, right? So since we're leveraging what they already have, the infrastructure team already has, and mirroring traffic from it, the only real conversation we're going to have is what's your volume of traffic, and are you going to add overhead, any significant or noticeable overhead to whatever you have in line that we're going to mirror traffic from by telling it to mirror the traffic, right? So that's really the only, it's like a slight con to the pro, but the idea is that everyone's going to be happier if they're very worried about touching anything that already exists. And if the app API teams are worried about any increased latency or anything like that, we're just saying, oh, no, we're just sitting on the side, getting traffic from whatever already exists there. So we're doing inspection only. We're flipping a kind of a con into a pro here, and saying it results in no application latency. So again, because we're not putting anything net new in line, we're not adding new network hops in the front or the back, and no new encrypt decrypt cycles. There's going to be no impact to latency. And typically in the async fashion, it's just a fire and forget. So it's the main application path or API or packet path is going to be not impacted by this type of deployment. In some cases, like we did in the diagramming, it can allow us to get that deeper access and allow us to get north, south, and east-west traffic. But the nuance here, I would say, is we don't wrap our head around north, south, east, west, and we have to go to the out-of-band or out-of-line deployment. This is where it's always there's lots of different options on the table, on the menu. One of the nice things about working with us, and we approach our customers and like consultants really, and working with you, is we dive into your specific needs, what you want to get out of the solution, and work with what you have and your infrastructure to pull the pieces and parts in and build a solution for you that makes sense for solving the problems you want to. And so it might end up that we use an inline or blocking capable north-south piece, and then for the east-west traffic, use something like this completely out of line and just sniff the traffic like eBPF in a Kubernetes cluster or any of the other mirroring options from an existing load balancer or API gateway or something like that.
Sure. So the cons, the biggest one is you can't block real-time traffic, right? So the only thing that you're going to be blocking by is large scale or every request from a particular IP that we've talked about quite a bit. That's one of the biggest negatives about out-of-band, eBPF, TCP mirroring, span port mirroring. All of those we can do, but the problem is you're only going to watch the attacks. You aren't going to be able to block the attacks. I'm not a big fan of just watching attacks. I like to block those so that I can see that we block them. But sometimes this is a good way to get into the product, which is mirroring a traffic so that you don't have any of the other cons across the other deployments. It can be complex because it has a lot of moving parts. So a lot just depends on how you deploy it. But if you've got multiple data centers and we're trying to get span ports out of every core switches, it can just take time and resources to get all those moving parts put together. And then last but surely not least, I guess we really want to talk about our next webinar.
Yeah.
Uh,
The
connectors.
The connectors, right? So again, kind of shares a pro from the last one, and the no architecture changes typically required, right? If you the only change you would consider is that you're adding some kind of plugin or policy to an existing solution. It's very quick deployment. And well, like I already mentioned before, that quick on and off capability, right? So we can either start on or start off with the deployment, but quickly add that mitigation or synchronous connection when we're comfortable, or if we, like I said, see interesting things in the data and see a very real need and a case to add mitigation to any attacks or abuse that we might see in the data. We build short circuits into all of our connectors. So, and those are typically configurable. And what I mean by that is there's some sort of delay or something. If there's any delay from the filtering nodes processing the traffic, you set a threshold, and if we breach that threshold, the system will fail open and allow the traffic in. So it's basically, if you have that switch turned on to have that synchronous or in-band blocking capability on, and something happens to the connectivity to the filtering nodes that are doing the processing and making that decision, we will fail open and allow the traffic through. So the idea is, this is kind of best of both worlds, because if we go back to the initial in-band deployment types, right, we're putting something net new in the line of traffic. If that thing fails, that's going to possibly cause an outage depending on the HA that's configured, right? But in this case, with the connector, we get that in-band plus the immediately failure proof of the short circuit. And then we have the async or sync, I think kind of covered that. And then obviously this one again shares that similar pro of that easier buy-in from infrastructure and app API teams, because again, we're not making any changes to architecture, and we're not adding any latency or network hops.
Yeah, great. And really the biggest and only con is really the cost of running the connector. There are certain costs depending on the device. So Cloudflare workers have a cost to them depending on your contract. CloudFront with Amazon, with an Amazon Lambda, they have costs for that as well. So does Akamai. So it just depends on which connector you're using and what that might look like. So not many cons for the connector. There's a lot of great things about the connector, as Brandon went over. And we use connectors a lot. We test them a lot. We use them with customers a lot, specifically because there's very little architecture change that's needed to them. So in wrap up, Brandon, is there a right or wrong way to deploy API security products? No.
And I would question any vendor that tells you otherwise, right? And that's one of the nice things I think about. Like I said, I'll go back to working with us and our team, is that we're not going to tell you how to do it, or that this is the way to do it, or this is the only way to do it, or that the way you're thinking is wrong, or anything like that. We're going to land on the right deployment for you. And that's why we've built so many different things on the menu, which can be overwhelming. But if you go to our documentation, we're very transparent company. So you can go to our website and see all of our documentation, all of our deployments, all of our menu. But that's what, you leverage our experience and our consultation to work with you to navigate that menu and find what is right for you. Because there is no right or wrong for API security. And a lot of it dictates, like, what do you want to get out of it? What problem do you want to solve today? And that's what we work with you to find out.
Yeah, we spend a lot of time on what is it that you want to get out of the product or out of the project that you're working on, especially when you're API security. There's so many things you can get out of it. So it goes right along into the second question: is there just one way to deploy Wallarm or an API security product? And we covered that, which is there isn't just one deployment model that you have to pick. We have lots of different deployment models. We have lots of customers that are doing more than one deployment model, depending on their architecture. We have some people using 4, 5, or 6 different deployment options because of how vast their architecture is internal to the organization. So there isn't just one way to deploy. We like it when our customers choose many ways because that means they're getting the best coverage across their organization, depending on what they have in their organization. And then the last one, like we've talked about, requirements should guide your way for each environment. As you're choosing a product, as you're thinking about what you're going to implement, make sure you understand your requirements and let those requirements guide your way on how you want to deploy a product and what type of deployment that you choose. And Brandon and I talk about this a lot. We've talked about it a lot on this webinar. Deployments and your requirements go hand in hand. And so to get the organization aligned on requirements is hard, and it's something that we do every day, and we like working with customers to do that. So Brandon, thanks so much for joining me, and I appreciate you and all of the work that we've done together. Brandon Brown, if you want to jump in, and we'll do the last few slides.
Yeah, thank you.
Yeah,
Thank you everyone for your time. Appreciate it.
Yes, thank you, Brandon. Thank you, Tim. We're just gonna have 2 more slides we'll cover shortly here. So we're gonna have next Wallarm event is gonna be the New York API Security Summit. It's on October 10th at the Hard Rock Hotel. It's a group for local folks in the industry. And we'll have a couple different keynotes, a panel of also some of the other local industry experts, and then we'll cap it off with free lunch and free breakfast for you. So if you or any colleagues are in the area and you think you might benefit from this, it is free registration. I'm going to drop the link in the Zoom chat and as well in the LinkedIn chat. So either way, you should see now the link for the New York event in both of those chats. And then if you want to go ahead and go to the next slide, we can talk about our next webinar. All right, awesome. So our next webinar, quarterly, the Wallarm research team, they put a lot of effort into coming up with what we call the API Threat Stats Report. So our next webinar, our CEO and co-founder and our VP of products, they'll be going over the reports and kind of going over the highlights, letting you know about the trends to look forward, moving into the rest of the year here. So in addition to that, I'm also going to drop a link to register for that as well. So if you're interested, there will be a link in both the Zoom chat and the LinkedIn chat. So that's about it for me. Either way, on both slides, there are QR codes there. So if you guys register in Zoom, you will get the recording of this sent to you after, along with these additional links. If you are on LinkedIn, you'll also notice in the LinkedIn chat, there's a spot to register on Zoom if you want to get those communications. But that's about it. So I really appreciate it, guys. The links are coming in both LinkedIn and Zoom now. So thank you, everybody.
And as Brandon said, thanks everyone for being here. I appreciate y'all. We'll talk to you next time.